In March 2016, scientists in Japan published an extraordinary finding. After scooping up some sludge from outside a bottle recycling facility in Osaka, they discovered bacteria which had developed the ability to decompose, or eat, plastic. The bacteria, Ideonella sakaiensis, was only able to eat a particular kind of plastic called PET, from which bottles are commonly made, and it could not do so nearly fast enough to mitigate the tens of millions of tons of plastic waste that enter the environment every year. Still, this and a series of other breakthroughs in recent years mean it could one day be possible to build industrial-scale facilities where enzymes chomp on piles of landfill-bound plastic, or even to spray them on the mountains of plastic that accumulate in the ocean or in rivers. These advances are timely. By vastly increasing our use of single-use plastics such as masks and takeaway boxes, the COVID-19 pandemic has focused attention on the world's plastic waste crisis. Earth is on track to have as much plastic in the ocean as fish by weight by 2050, according to one estimate. However, experts caution that large-scale commercial use of plastic-eating microorganisms is still years away, while their potential release in the environment, even if practical, could create more issues than it solves. Overcoming an evolutionary barrier, the scientists working to find and develop plastic-eating organisms must contend with a basic reality: evolution. Microbes have had millions of years to learn how to biodegrade organic matter such as fruits and tree bark. They have had barely any time at all to learn to decompose plastics, which did not exist on Earth at any scale before roughly 1950. Seaweed has been around for hundreds of millions of years, so there is a variety of microbes and organisms that can break it down, said Pierre-Yves Paslier, the co-founder of a British company, Notpla, that is using seaweed and other plants to make films and coatings that could replace some types of plastic packaging. By contrast, plastic is very new, he said. Still, recent discoveries of plastic-eating microorganisms show that evolution is already getting to work. A year after the 2016 discovery of Ideonella sakaiensis in Osaka, scientists reported a fungus able to degrade plastic at a waste disposal site in Islamabad, Pakistan. In 2019, a biology student at Reed College in Oregon showed that samples from an oil site near her home in Houston, Texas, contained plastic-eating bacteria. In March 2020, German scientists discovered strains of bacteria capable of degrading polyurethane plastic after collecting soil from a brittle plastic waste site in Leipzig. In order to make any of these naturally occurring bacteria useful, they must be bioengineered to degrade plastic hundreds or thousands of times faster. Scientists have enjoyed some breakthroughs here, too. In 2018, scientists in the UK and US